let me move into the partial correlation. I can give some kind of definitions over here so that can also be added. So what is partial correlation? Partial correlation is nothing but correlation between an a dependent variable and one particular independent variable. There can be many independent variables, and I'm saying only one particular independent variable by keeping all other independent variable as constant. So this is actually called as partial correlation, right? So please let me know whether the font sizes are okay, or I need to zoom somewhat the word screen. Please let me know whether the font size is okay, or I need to zoom somewhat, students. This particular portion is most important for your evaluation, so please be more active here and please respond. Okay, whether the font size is okay.
Okay, sir.
Yes, only Nitish Reddy is present in the class.
Okay,
Okay,
sir.
Sir, keep 14.
pick 14. Okay.
Okay, sir.
Thank you. Good. Right. So this is actually the partial correlation function. We have many types here. So when going into the types of partial correlation, we can have partial correlation coefficient of zero order. So what is that zero order coefficient? We mean it as simple correlation where none of the variables is actually influenced. There is only one independent variable and one dependent variable, and correlation between those two will be studied by using the zero order partial correlation. Right. So we will directly move on to the partial correlation types, which starts from first order. Zero order is also a type, which we will discuss in the third one. First we will discuss first order, second order, then finally we will see zero order. Okay. So partial correlation from first order, when it will be first order in the sense here, one variable will be held constant among the set of independent variables. Example is, if you have three independent variables, or three variables, 1, 2 and the 3, the influence of or the correlation between 1 and the 2 can be studied by keeping t as constant. By keeping 3 as constant, and this particular thing can be represented as r r1. This can be represented as r12 dot 3, means that I'm going to study the relationship between 1 and 2 by keeping the third variable as constant. This we have already seen. Can anyone say what is the formula for this r12 dot 3? Anyone? Anyone, if you remember, can you say what is the formula for r12 dot 3? No one remember, huh?
Square root of.
Great. Square root of, let me take the division away. Loading for yes. So I need to put one square root also. Where is this? Yes, square root of. If I was want to,
R12 square.
yes, r12 squared
Minus
1 minute. Why is actually
Yes.
the latex is making some kind of. That is actually slow here. And R12 squared you want, right? I think whether it is understandable R12 squared, not understandable, right? Just a minute. So you're actually going to use R12.3 and not R1.23, right? Yesterday we saw R1.23, and for R1.23 it is square root of R12 squared minus R12 squared plus R13 squared minus 2 R12 R13 R23 divided by 1 minus R23 squared. That is what we did yesterday. But this is actually different. This is actually with respect to first order, where I am having R12.3. So everything must to go with respect to 3. Let me write it here. Now the formula for this will be, I'll take so no, one formula is there. We can actually use that to write other formulas. It will be R12 minus R1323. It can write it as R13 and R23. We have like this, right? Here it is R12.3. So it is R12 minus R13 R23. This is actually the first order of the thing. And I divide it by the square root of R1 minus R13 squared into 1 minus R23 squared. So that is actually the new formula we are learning today, right? I'll put that also. One minus R13 squared R23 squared. So this is actually the formula for R12.3. That is R12 minus R13 R23 whole divided by square root of 1 minus R13 square into R23 square. So this is actually the formula. What is actually happening is I am actually making all the normalization with respect to the third variable, which is made as constant. The variable which is made constant is 3. So only we kept as R12.3. Since one variable is kept as constant, it is called as first order partial correlation because one variable is kept as constant. Similarly, just try to say me what will be R uh, 13.2. What will be R13.2? Anyone? Can anyone say what will be R13.2?
R13 minus
Yes, R13 minus
R12
R1 to R
R12 R32 whole
R32
divided by square root of
1 minus R12 square
and R
1 3 square.
R13 squared into what next? R32 squared. So the changes should be I have to do what I have to do here is this is R13 minus R12
1 2
and here it is uh,
3 2
here it is again 3. Similarly, we'll write one more that is R R23 dot on. That is the final one. R23 dot. So this also will be the same. I want to take R21 minus R, sorry, R23 minus R21 into R31 whole divided by square root of 1 minus R21 squared into 1 minus R31 squared, right? Take this, I paste here. What will be the formula here? Instead of 1 3, I need to write 2 3, and here it is 2 1. Okay, if I was going wrong, please correct. Okay, 3 1. Here it is also 3 1. Here it is 2 1. Right? As I said yesterday, R21 and R12 are symmetric. So both are exactly the same thing, right? Correlation between 1 and 2 or correlation between 2 and 1, both same. So this is the effect, and this is actually called as first order partial correlation coefficient. And these are the formulas. Right? This is good, right? Yes, this is good.
Yes, sir.
Yes. Well, I go for the next. That is partial correlation coefficient of second order. So what will be in the second order? Two variables will be held constant among the set of independent variables. So the same thing. Example, if you have here, if you have four variables, say four variables, because if I have three variables, I cannot go for second order because I want at least one variable into consideration. So, for the dependent variable, so I go with the minimum of four variables. So say 1, comma 2, comma 3, and 4. The correlation between 1 and 2 can be studied by keeping 3 and 4 as constant. How can we represent this in R in terms of R? How can I represent this R? How can I represent this
12.3.
1, 2, 3.
R12 dot 34? Am I right? R12 dot 34 means that I'm going to study R12 by keeping 3 and 4 as constant. Right? I'm going to study R12 by keeping 3 and 4 as constant. Right? So here the ultimate constant is going to be the fourth, the final thing, and based on that 3 will become constant, and based on 3 and 4 being as constant, 1 and 2 will be measured. Right? Now just to see these formulas, with the help of these formulas itself, we can easily find what is the formula for R12 dot 34. Right? So I'll write that formula. If you look at this R12 dot 3, the same thing we can also write here with respect to R12 dot 34. R12 dot 34, which will be equal to my main study should be with respect to R12 by keeping 4 as constant first. Next, normalize with respect to 3 and 4 for studying the correlation between R1, 2. Right? So this is the case. So what I will do, R12 dot 4 will be the first one. R12 dot 4 minus R13 dot 4 into R23 dot 4. Dot 4. So I want to study R12 dot 4 minus R13.4 into R23.4 whole divided by this entire term should be in a derivation term. Square root of 1 minus the same thing will come here. What is coming here? 13.13.4 and 23.4 is available. The same thing I'll write here. R1 13.4 whole square. I need R13.4 whole square into 1 minus, just copy this for using it again. Here it is R23.4. So this is actually the formula, that is R12.34 will be R12.4 minus R13.4 into R23.4. That is 13.4, 23.4 whole divided by the same thing. What are the things we are going to normalize? This 13.4 and 23.4 we are going to normalize. So this is the formula for partial correlation coefficient of second order, right? So now can you try to say what will be R? I'll take this R underscore 13.24. Can anyone say what will be the formula for R13.24? What will be R13.24? That is studying correlation between 1 and 3 by keeping 2 and 4 as constant. How can I do this? Can anyone say?
Sir, R13.4 minus
Minus
R124
12.4 into
R134 minus R124 and R324
yes whole divided by
12.4 minus R1
same thing whatever you
12.4.
wrote here. Great.
Yes, sir.
Same thing what is coming in the numerator subtraction you'll use here. That's what you are also saying, right?
Yes, sir.
So it will be like Narasimha said, it is R13.4, that is the final constant on 3.4 minus
R12.4.
R12.4 into
32.4.
R32.4. Here also the same thing will come down, that is R12.4 into R or 32 and 23 are same. Just for understanding, we are writing it again 32.4. Yes. Similarly, we can also try for one more thing, that is let us keep this 4 inside and study the correlation between 1 and 4 by keeping 3 and 2 as constant. So if I ask in a question, like I will be asking like a theoretical question, find the correlation between first variable and fourth variable by keeping the other variables as constant. Then what will be your formula? This will be my question, right? Then what will be your formula? Find the correlation between first variable and fourth variable by keeping the other independent variables as constant. Then what will be your formula?
R14.23.
R14.23. Great, correct. So can you say why it is R14.23? What is the explanation for this 14.23?
You said, sir, what? 2, 3 is constant, sir.
Yes. So as per the question, want to find correlation between 1 and 4 by keeping 2 and 3 as constant, right? Yes. Now we will go with the formula. I'll take this entire thing, just we can do editing here. And before that, anyone know, want to say the formula? Can you find the formula for 14.23? See, this time the final constant is 3. Based on that, you have to say. Anyone can try? What will be the formula? What will be the formula for this? R14.23.
R14.3.
1 minute. R14.2. Sorry, R14.3
3
minus
minus
R12.3.
R123.3.
Next,
42.3.
42.3. Next, the same thing will be normalized in the denominator. That is
R12.3.
12. Great. Great. This side, 42.
42.3.
So everyone understood, right, how to frame the formulas, right? So R14.23 will be R14.3 minus R12.3 into R42.3 whole divided by square root of 1 minus the same thing what you write here, R12.3 the whole square into 1 minus R42.3 the whole square, right? This is the case, right? So far so good. Everyone can understand up to this, right? I'll also explain. Given the ultimate is will be given a table of x and y values only. From that x and y values, you need to calculate what is zero order correlation. Next, you should calculate first order correlation. Then only you can calculate R14. If I ask the question like find the second order correlation, for finding the second order correlation, see in the formula you require the first order correlation. So first you have to find the first order correlations available here. Then for finding the first order correlation, you need the zero order correlations. Then only for finding zero order correlation, now we need the normal formula which can be used directly from the data set, right? So that is what you have to do. Now I'll go into that basic correlation formula. Basic correlation formula. So this is the case. Now we need to find what is the correlation of two variables. Correlation of two variables 1 and 2 can be given as R12, right? R12 without any without making any variables as constant. I need to find just the correlation between 1 and 2. So how can I do this is let me take the sum summation x1 into x2 divided by square root of summation x1 squared into x2 squared. So I have to take this x1 squared into summation x2 squared. This is actually the formula for calculating R12. That is summation x1 x2 divided by square root of summation x1 squared into x summation x2 squared. This is actually the formula for calculating the correlation of two zero order variables. That is zero order in the sense none of the variable is made as constant. Similarly, if I want to take R13, I can write it as same thing. Instead of x1, x2, I can write it as x1, x3. That is actually the difference. X1, x3. Here also x1, x3. Finally, if I want to write R23, I can write it as x2, x3 into summation x2 squared into summation x3 squared. Yes. So this from using this, for example, if we are given a table, we should use the table to find how these values are going to be get estimated, right? Yesterday we saw the multiple correlation coefficient, and today we saw partial correlation coefficient. In partial correlation coefficient, we have seen that given a table, how to calculate the simple correlation we know, and once the simple correlation is computed, I can go for finding the first order correlation and use that to find the second order correlation, and so on. I can have any number of correlation coefficients, right? So now we will be going with a very small example over here, right? So this let me take one problem that can cover as much as thing as possible. I'll take from one of the book exercise. Yes, right. Let us have something like this. I have x1, x2, x3 ready, and the values of x1 are 20, 15, 25. We can give randomly also. So let me 40, 38, 28, 14, 18, 15, 23, 14, 12, 13, 16, 15, 13, 15, 12, and 16. So we have a table like this. So these two are not needed. Yes. Now what is the thing is we need to find the correlation coefficients are 1, 2, 1, 2.3, or 1, 3.2, or 2, 3.1. These things we have to find. So what will be the procedure is very simple. First, if I want to calculate R13, 12.3, what is the formula? I need to calculate R12 minus R13 into 23 whole divided by square root of 1 minus R13 squared into square root of R12 squared. Sorry, 23 squared. This is what the formula. So for finding those, I need what is R12, R13, R12, everything, because this is the formula. So for substituting in this formula, I need to find what is R12, R13, everything. So for finding this, I need to calculate the basic correlation relations. So I need to calculate what is x1 squared, x2 squared, x1, x2, everything I have to calculate. Yes, we will do that. Let's insert a table. X1, x2, x3, x1, x2, x1 squared, x2 squared, x3 squared, x1, x2, x2, x3, x1, x3. So this many numbers needed. So this is x1 and this is x2. This is x3. This is x1 squared. This is x2 squared. This is x3 squared. This is x1 into x2. This is x1 into x3, and this is x1 x2 dot x3. So this is what we have. So we'll substitute this over here. 20, 15, 25, 26, 28, 40, 38, 12, 13, 16, 15, 23, 15, 28, 13. Anyone can help me in finding that squares and all. 15, 12, 16, 14, 18, and 14 again. Right? Shall we go off with the squares now? Can anyone say me that? 20 squared will be what?
400.
400. Yes, 400.
25.
15 squared is 225. Okay. This is
625.
625. 26 squared,
76.
676. Okay. This is, we know that it's 1600. Can anyone say what is 28 squared?
784.
784. 38 squared,
1444.
1444. Okay. Similarly, here it is 144, 169, and this is what is 256. Huh? Correct?
Yes, sir.
Yes. Next to 15 squared is 235. 23 we need to calculate. This is 225, and 28 we already have 784. What is this 23 squared?
529.
529. Great. Next x3. This is 169, 225, 144, 256. 14 squared 196. Huh?
Yes, sir.
Yes. 18 squared we already calculated. Huh? No, right. 14 squared is again 196.
324, sir. 18 square.
18 squared is 324. 18 squared 324. Now x1 into x2. I think this will be easy compared to the finding that. This is 1, 2, 3, 4, 5, 6, 7. 7 items are there. So we can now proceed into that. X1 into x2 we have to calculate. What is x1 into x2? That is 20 into 12, 240. 15 into 13,
195.
195. 25 into 16,
400.
400. 26 into 15,
390.
390. 28 into 23, 600 I think.
44.
644. Okay.
1064.
1064. X1, X3. 20 into 13, 260. 15 into 15, 225. 25 into 12. 25 into 12,
300.
300. 26 into 16,
416.
416. 28 into 14,
392.
392. 40 into 18,
720, sir. 720.
720. Okay, okay. 38 into 14,
532.
532. Final thing, x2 dot x3, that is 12 into 13,
156.
56.
156, 13 into 15,
195. 195.
195, 195, 16 into 12,
192.
192.
okay, 15 into 16, already we have, right,
240.
240, 23 into 14,
322.
322, 15 into 18,
270.
270, 28 into 14,
392.
390. So now we can take the summations of these. So summation. So if I add, I want to add all these 400 to 25 these things. If I add, what will come? 400 plus 225 plus 625 plus 676 plus 784 plus 1600 plus 1444.
5754.
5754. Okay, I take that. What will be this? 144 plus 169 plus 256 plus 225 plus 529 plus 225 plus 780. Everyone calculate one first so that we can complete soon. Should have used
2332, sir.
Excel 2322. Okay.
2332, sir.
Okay. 2332.
Yes, sir.
Okay. Okay, Param. X3 squared summation
510, sir.
of 1510. Okay. 1510. Next. X
3513, sir.
3531. Okay.
33, sir.
33. Next X1, X3. What is X1 into X3? And what is X2 into X3?
Sir, x2 into x3, 1767.
1767. This Pavani, this one,
2845.
2845. So these are the summation values. Hope all of them are getting something the same thing, right? So which is where our solution actually began. So now you can easily put it in the formula. First we calculate the total correlation. What is total correlation? In the sense there is no partiality applied. Partiality in the sense no constant thing. So we just find R12. What is R? We can take the formula from there. This is R12. This is R12. So what will be the value for R12? We take a summation x1, x2 as you said, summation x1, x2. Where is summation x1, x2? We have this x1 and x2 is here 3533 and square. So we will take that. So instead of x1, x2, we substitute the value of x1, x2 summation 3533. And what is summation x1 squared? Summation x1 squared is here 5754 into, and summation x1 x2 is actually summation x2 squared is actually 2322. So what is the we want to calculate the value of this? This will be equal to 3533 divided by, again we want to go with this. So we will multiply this. I'll take the calculator. If anyone calculated, let me. 5754 into 2322. You need to take square root. So I'm getting 3655 for this. If you are also getting me, please acknowledge. 3655.24. If every all are getting this, others are getting this. Friends, are you getting this? Friends, are you getting this? Please answer. Can you hear me? Any problem with
Calculating.
Oh, okay. Then I get 0.966 as the result final answer. 0.9665. 557 it is going like this. This is R12. Right? Hope everyone are getting the same.
Sir,
Yes.
final answer I got 0.9644.
Whether this is right, 3655.24.
That I got 3663.1.
By multiplying these two, 5754 into 232, 2332. Sorry.
Yes.
I mean, yes. So what is this here over here in the denominator?
3663.1.
63.10 or something. Yeah?
10, sir.
Sir, final answer 0.972, sir.
Anyone, Narasimha, any common? One is saying 96. What is full answer, Harini?
0.9644.
Narasimha, yours 97.
Sir, I am getting 972. 0.972.
More increase is there. 9644 is one. Whether you are getting the
Nine
denominator
six
the same,
double
pa?
four eight. 0.9644, sir.
Okay, Pavani, Sasi also said the same. Narasimha, can you check one more time, Narasimha?
Okay, sir.
Yes. So we go with this. Similarly, we find R13, R23, and so and we will be substituting it for finding R12.3, 13.2, and 23.2. Right? Now, just to say me one particular thing, how much time will it take to do this task so that I can give that much mark for this? When I ask for quiz evaluation or some other open book test or something, how much time is required to compute R12, or how much time is required for computing R12.3? 1 minute or 2 minutes, like that, or more time is needed? You itself say now itself so that I can fix mark accordingly.
3 to 4 minutes, sir.
3 to 4 minutes for computing R12.3 or computing R12 itself.
R12.3, sir.
Okay, for computing. So once this table is for computing this table, how much time is needed? This table can be computed in 2 minutes, huh? Or more
Yes,
than
sir.
seven items will be given. Here there are 7 items. We can fix more than 7. We don't want. We let us have like 7. For computing this, you can make being in online. You can make use of Excels also, so you can be even more faster. So can for example R12 can be for 2 marks. R12.3 can be 1 mark. If R12 is ready, this can be for 2, like this.